Welcome to Chapter 4 of JavaScript 6th edition. In this chapter, we're going to go over debugging and error handling in JavaScript. So, the objectives of this course, or this chapter in general, is to go over error handling and debugging. So, let's talk about debugging. Debugging is a way of removing bugs from the code. So let's talk a little bit more about what that means. Most programming languages, if not all programming languages, have a little something called syntax. And what syntax really means is how the code is written, or the rules of the code. In a sense, how it's supposed to be written. Just like in any written language, there's a certain way that you say things. For instance, in English, we say the red car. We have the article, the adjective red, and the noun car. In Spanish, or French, or most other Romance languages, the syntax of the language is completely different, or the rules of the language are completely different. For instance, in Spanish, in order to say the word or the phrase, the red car, you wouldn't say the red car in that way. The rules state that you have to instantiate the noun in the language, in the sentence, before you try to describe it. So, in Spanish, we would say el carro rojo, or the car red. If you said el rojo carro in Spanish, that would make no sense. The red, meaning the adjective red, the adjective cannot come before the noun. The same syntax rules that we see in written languages are apparent in programming. So, to use that example, in programming, we can't describe a variable, we can't load a variable with any value whatsoever unless we first instantiated or initialized it. So in the instance of a syntax rule, that we would look at a variable on the left side of an expression and the data being assigned to the variable on the right side of the expression, kind of like in Spanish and French. Logic, on the other hand, is how the program executes. What functions, what methods, what parameters and arguments are being used to execute the program. The logic of the program can change based on the way the developer developed the program. The logic is not always the same. Sometimes, and in most instances, it can be different across different languages. So what's a bug? A bug is any program error, syntax or logic-based. Now, remember I said that logic is the way that the program is executed based upon how the developer develops the language or develops the program. However, there are certain situations where you would instantiate or initialize or call a method or function that you either wrote or that is already inherent to the library incorrectly. For instance, in C#, you can't call a function or a method that requires an argument without using a parameter, or that requires a parameter without first entering the argument. It's a little more complex. I'm not going to go too deep into it, but that's a certain situation where the logic is being broken. In most situations, though, in most written program bugs, you will find, in my humble opinion, you will find that 90% of most bugs you find in programming are syntax-based, meaning that the programmer, the developer, wrote the program incorrectly. They did not adhere to the rules of the language. And thus, you have syntax errors. If you look at some of your guided practices, you'll find a truckload of syntax errors. And it's up to you to correct those syntax errors using console. Now, what's debugging? It's just that. Finding the bugs and then trying to resolve those bugs in the program. Once again, in most situations, you will find that syntax errors rule the day. So, syntax errors can be recognized by the interpreter, and there are certain situations where they can't. This normally happens when, like I said before, the line or the functional statement is not written correctly, meaning that it's not written with the right characters. So, or written in the wrong way. Let's take an example, for instance. Switch over to the code. I have a line of code here, var bug equals, and then I have the string, the literal string 1, the integer 2, the literal string 3, And then I didn't put a bracket at the end. Obviously, you can see there's an error here. Expected bracket at the end. This is a syntax error. I purposefully did this to show you what a syntax error may look like. Now let's open up console, or let's open up the console view, and let's try to run this to see what happens. And true to form, we get a syntax error. I hope you can read that. Syntax error. The reason why we get a syntax error is because this is not written correctly. It even tells me what I need. This is actually rare. This is not necessarily going to happen 100% of the time. I wouldn't say rare, but it won't happen 100% of the time. It won't tell you what the actual error is. Normally, the error will tell you something before or after it couldn't run because there's an error before that line. In this case, there's only one line, so it can tell you exactly what the problem is. And JS Fiddle is good for that. That's why I like JS Fiddle so much. So I'll put a bracket here, and we'll rerun this. And the error should, if I clear all my errors, the error should not appear anymore. If I console log bug, or the variable or the array bug, actually, if I console log the array bug, I should get the array and everything that's in it based on what I loaded into the array. If I remove this bracket again and try to run, I will get an error. Unexpected token, and it won't run the next line. Console.log bug did not run because the syntax error forces the program to stop at that line. This is a syntax error. All right, let's switch back over. Runtime errors occur when the interpreter encounters a problem while the program is executing. This is normally a logic-based issue or an issue with the interpreter. And normally this happens when the interpreter cannot execute a line of code or the function statement. A runtime error can also be caused by a syntax error. Now, what you saw when I tried to run this JS Fiddle application with the error is that the runtime error was handled by the interpreter. It returned to me not only, and I'll switch over so you can see what I'm talking about, it returned to me not only the error that I received, but it also returned to me the line that error is on. Now, of course, this says line 1. When it says 67, it's talking about the actual JavaScript. So I would have to go to the source, go to the index file, or I can just click it actually. I can click it, and it'll show me line 67, and it'll show me the line that it tried to interpret in the browser. Either way, look a little closer at this error. This error doesn't tell me I'm missing a bracket. This error is telling me that something is missing before the semicolon. The semicolon denotes that it's the end of the function statement. However, there is something missing before the end of the function statement. It might not necessarily know what that is, but it does know that something is missing because it couldn't run it. JS Fiddle itself knows what is missing because it's an IDE. Your browser is not an IDE, it's just an interpreter. Therefore, it can't necessarily tell you what is missing. And more times than not, you will find that JavaScript is hard to debug when you're not using an IDE like JS Fiddle because the browser doesn't really know what's wrong. It just knows it didn't run. Let's switch back over. So logic errors are a flaw in the program's design, which means that the program is not running as intended. So let's take, for instance, the infinite loop that we had in the last chapter. We wrote everything correctly. There were no syntax errors. But as you saw, the browser froze. And when we went to the console view, the loop kept running over and over again. It was doing what it was supposed to do. The syntax wasn't the problem was the logic. We didn't write enough logic into the code to do what it was supposed to do. So in this case, we have a var division result, and we're doing a multiplication fact here. However, what we wrote is that 10 divided by 2 is equal to whatever the division result is. Well, that's an issue. Not because it's wrong, or not because it's wrong syntactically, or that you'll get an error from the interpreter. No, this will run just fine. The problem is logic driven. We didn't divide 10 by 2. We multiplied 10 multiplied by 10 times 2. So logically, this is not correct, and we're not going to get the desired results. These errors are harder to catch, which is why we have quality assurance engineers and technicians that help us catch these types of errors that might not be thrown by the interpreter or even the IDE. We went over infinite loops in chapter 2, but we can go over it again. In this case, we have a for loop, my favorite, next to for each, and in the for loop, we have the variable count that's initialized as our counter. We then have a parameter, count is greater than or equal to, greater than or equal to 0, count. Now, what's the problem here? Can anybody see the problem? This loop will run infinitely, but why? Well, if we look at the corrected infinite loop, you'll find that we want this count variable to decrement by 1 down to 10 to count off. However, in the first loop, we didn't do that. All we did was say count, meaning that we called the variable count, but we didn't give it any decrement or increment or any required action. Therefore, what will happen is count will stay 10 infinitely, and this loop will run infinitely because count stayed the number 10. Once again, as I said in the last chapter, this can be a big issue when you're running on, a group of servers or even in Azure and you have an infinite loop. It can run up the cost of your cloud compute. It can make issues with usability of the web application or the application in general. It can even bring the servers down based on a false positive for a DDoS attack. I'm not going to go too deep into that, but infinite loops can be extremely bad. So, how do we interpret error message? The first line of defense is locating bugs. The browser console displays the line error, what we talked about in the last error. It displays the line error that it occurred at and the error description. It is not every day that you'll get the exact error description that you're looking for to remediate the problem, but it can lead you to where that problem exists and you as a developer can remediate it. Runtime errors generate messages in the web browser. Now, if every error generated in the web browser, you would probably bug out your users. Your browser is always going to throw some type of error. It always does. Something is not written to the specification of the language. That doesn't mean that that error is going to stop whatever is trying to run at the browser level from running. It just means that there's something wrong and you should probably take a look at it. A recommended change, but not necessarily a runtime error that would stop the browser from doing what it needs to do. Now, if there's a runtime error, you want that error to display in the page. You want to know that there's a problem, and you want to notify the user that either they made the problem through a user entry, or that they need to notify their system administrator that there is a problem so it can be remediated on the back end. Now, runtime errors can be caused by syntax errors, but not by logic errors. And the reason why is because 9 times out of 10, you'll have a try-catch that's catching that exception and sending it back to the browser to display. So in this case, missing closing brace, we have the variable message being instantiated, and then we have the name of the message. This function is missing a closing brace. And then what we did was we have that alert available to us when this function is executed. You can actually place this function in an exception for a catch statement, and it will throw and giving you the error you're looking for. And this is something that we looked at in Chrome, where you have your console that's giving you errors. Syntax error, reference error. Now, reference error is different from syntax in that, well, it's not different, but it is still quite literally a syntax error. Something is missing. No bracket after the body. Missing closing brace is not defined. 9 times out of 10, that's because it's syntactically not written correctly, or the program doesn't know that it exists. So the error message, it displays the general location in a program, but it's not an exact indicator. As I said before, and as we saw in the debugger for JS Fiddle, it didn't tell us that there was a missing bracket. What the error told us was there's a syntax error. However, I don't know what it should be syntactically. I just know I couldn't run it. Now the JS Fiddle IDE knew what the syntax error was because it can look at what we wrote and say this looks like it should be an array. Hey, you're missing a bracket. Browsers do not strictly enforce JavaScript syntax, and that's very important. Mitigating bugs in JavaScript programs means that as the developer, you must always use good syntax. That's why you see I always use lowercase. It is recommended and highly recommended in every scripting language that you pay close attention to and be reverent of the fact that it's case sensitive. Everything in scripting languages, for the most part, are case sensitive. That's from Perl, PowerShell, JavaScript, PHP. It's all case sensitive. So when you find most JavaScript code, most times you'll find it not being camel case. What's camel case? Camel case is when you have two words that are mashed together. The first word is lowercase, and the second word has the first character uppercase. That's camel case. Now, normally, in older developers' mindsets, camel case is good for C# because it's not case dependent. However, JavaScript is. Camel case can be a problem. So always use good syntax. Thoroughly test every browser type and version. IE8 has a lot of JavaScript engine non-dependencies that the Internet Explorer versions after it don't have. Thus, we need to be cognizant of what every browser can do and what each type of browser can or cannot do. I use Chrome because Chrome has the most forward. I'm going to say this, and I'm not trying to market for Chrome, but Chrome has the best JavaScript engine of any browser on the market. Even with Edge, it's still the best. And that's why I use Chrome without fail. It just is the best. But you have to pay attention to the browsers that you're using and the browser in your environment. Just because Chrome might be your favorite doesn't mean that Chrome is the de facto browser version that's being used by your enterprise at your job. 9 times out of 10, because Internet Explorer and Edge can be remediated at the group policy level, your Internet Explorer would more than likely be the browser of choice that is implemented by your information governance policy at your organization. You have to stay cognizant of that. And yes, Internet Explorer is the bane of most developers' existence because of its inability to meet the requirements of some programming nuances that we enjoy, but it's a necessary evil, and we have to pay attention to that. That's why we try to use backwards compatible bindings to account for that. So syntax errors can be difficult to pinpoint. Common techniques are helpful in tracking down bugs. Tracing. So tracing is basically examining the statements in an executed program. And then we use the window alert method, or alert. You don't have to necessarily say window.alert. You can just say alert. Is a useful way to display that error in the browser when it's running. You can place different points within your program, and then you call that window.alert method to check the value as the code executes. Let's say you have an issue in your code and you want to find out why it's doing what it does. You can use windows.alert to trace the code. If it's not returning the right result, you can see where along the way is that variable or that data being corrupted or manipulated in a method that you don't want it to be manipulated in. Now, obviously, in my example, I did not use alert. I use console.log. The reason why is if I did alert here, so let's say I made this correct, and I said alert. The alert method, the alert method cannot render arrays and hash tables. And those are the two data types or data structures I use the most. It'll only tell me, well, in the past it didn't. I guess I'm incorrect here. Or maybe Chrome updated it. But in the past, it wouldn't tell me what was in the array. All it would tell me is this is an array element. So I would use console.log to give me what's in the array. And it also gives me a lot more information than the alert does. So here's a function that is leveraging the alert method. We have the variable pay rate and the variable num hours being initialized with integer 15, integer 40. We have a pay rate times num hours gross pay function or expression, or I guess not condition but expression, that is multiplying pay rate times num hours and then assigning that value to gross pay. Now we want to check to see if that gross pay is correct. We essentially call gross pay in window.alert, and that will give us whatever is in the variable gross pay, as you just saw me do with the variable bug or the array bug. And this is a manual way to trace errors in your code without having to use any extra code like try, catch, or anything like that. Now, the drawback is, as I just said, it's a manual entry. So you yourself have to write it and try to catch the code bug where you think it may be. And you must close each dialog box for code to continue executing. So you want to use this selectively. And you want to place it at a different indent level so you know this is a debugging scenario. So you can erase it when your code goes into production. Now, I use console.log. I'm a big fan of it. I think that it gives you a lot more detail than the alert method does. It traces a bug by analyzing a list of values, and it can give you the value data type. It can give you the value position in the array. It can give you the key value pairs in a hash table. It is very good at displaying this information. I just like it better than any other debug trace if you're going to trace it manually. And here you go. The console.log, as you saw in my console when I had Chrome open, will display gross pay is and then the gross pay variable. Now, here's the problem with console.log. If console.log does not execute correctly, all the lines of code after it will not execute. Be wary about console.log. And if you have console.log in your development code, please, for the love of all that is holy, remove it when it goes to production. You do not want console.log executing in production. Like I said, there are certain situations where console.log will prohibit the function statements after it from running if a specific error or issue has executed. So I love console.log. It is very powerful, especially when you're trying to trace your own information, your own methods, and trace your own bugs. However, be aware, console.log can be the bane of your existence if it's still in your code come production. So please remove it. And here you go. This is exactly what console.log looks like if you write it yourself, rather than me just saying console.log and show me what's in an array. So a driver program is a simplified temporary program, and it contains only the code you are testing. Another method for locating bugs is to comment out problematic lines of your code. As you saw yesterday, or as you saw in chapter 3, if you watched that video, there were situations where I commented out my code so that the IDE would not recognize it. It would leave it alone. And that's nice when you want to see if a line of code is your issue. When you're manually tracing errors, especially in an IDE like JS Fiddle, or if you're not in an IDE like JS Fiddle, you have to trace it yourself. It can be a real pain if you're trying to go line by line to find out what's not working and what is working. However, if you can narrow down where the error is occurring, and normally if there's an error in JavaScript, it will disallow the function statements below that errored out function statement from running. Then you can start with the function statement that's disallowing everything else from running, whether it's a null value in something that you're trying to call, or whatever the case may be. This helps isolate the statement causing the error. And when the error message is first received, start by commenting out only the statement specified by the line number. Now, obviously, if you know what's wrong with the function statement, then just fix it and see if that remediates the problem. But there could be other issues that you'll run into. For instance, let's say you're doing a REST call out to something like Hacker News, and you're trying to pull in data. Now, you want to do something with that data, but in order to do something with that data, you have to load it to a variable or an array, and you want to deserialize the JSON. If the data doesn't come over, and then you still try to do something with the array, and there's nothing in the array, you'll probably get an error, object not referenced to an instance of an object. In that case, you might get an error at a line of code that isn't related to the actual error. The actual error could actually be lines above that code, not just one line, but many lines above that code, where the JSON call, the REST call, didn't pull back the data you were anticipating, and therefore you couldn't deserialize that array into something readable by the browser because there's nothing to deserialize. That's a situation where commenting out a statement of code can work to your benefit. You can comment out the code that doesn't work, or that you think doesn't work, until you get to the line that is actually making the error being thrown. So you want to combine debugging techniques. You want to use alert boxes and console.log to trace errors and use the comment out methods to comment out errors that exist if you're doing it manually. Now, any person that develops for a living will tell you that doing it manually can be quick, but it can be it's like going to Golden Corral or a buffet thinking that your stomach is bigger than it really is. And you can really drive up the amount of time that you're debugging if you only look at errors through a manual trace process. So if you're running into situations where you're having an error, it might be in your best interest to run try-catches to see what type of exception you are actually getting, rather than uncaught syntax errors or reference errors that you can't trace back to the problem. And that would increase the amount of time that it takes to remediate an issue. And here goes a combination of the window.alert method with commenting out code that you think may be the issue. So relationships in which one statement depends on another statement executing successfully is the definition of a dependency. Normally, when you're doing code, you'll have a lot of dependencies. Normally, when you're writing a program or a script file, you will have a lot of dependencies in your code. This is not a bad thing. It's actually rather good because that shows that you're using a forward-thinking logical paradigm to develop your code. Now, what this does, though, is it makes debugging a lot more challenging because you have to go through each dependency to find out which dependency failed and how to fix it. It is important to retest the program after fixing a bug to ensure other parts aren't affected by change. This is why error testing or testing in general with C#, writing your own test methods, is important because you can test the method even after it's been modified to see if it's still doing what it's supposed to do. So tracing errors with debugging tools is available in IE and Edge, Chrome, Firefox, and a couple of other browsers that have fallen off the wayside but are still used by a token few individuals who won't let them go. They are accessible through the same panel that opens when you use the console, F12. If you go to IE, it's still F12. If you go to Chrome, it's F12. I think Firefox is still F12, and I think Edge is F12. They're all F12. If you accidentally hit F11, what'll happen is it'll put your browser into full screen mode. That's how you know you're not hitting F12. I have a keyboard that has nothing on it. So sometimes I'm guessing what I'm hitting if I don't use that button a lot. Examining code manually usually takes a logic error being thrown. And it works fine with smaller programs. As I said, examining code manually is great if you have a small JavaScript file or there's not a lot of dependencies or it's something very simple. However, if it's not, and if it's a large MVC or whatever the case may be, using manual code debugging it just might make your life a living hell. Debugging tools like Chrome, Firefox, things of that nature help you to trace each line of code and is a more efficient method of finding and resolving logic errors. So, as I said, F12, and F12 also works for Firefox, and F12 also works for Chrome. You'll just have to click on console to get to the console version, or the console tab. But F12 works for all three of them. The debugger window usually separates the pane, as you saw. I'll actually switch over so you can see it. It separates the pane attached to the bottom of the browser. I can make it bigger or smaller. It won't cover the body of the page. I could also, in Chrome, change where this actually sits. I can tell it to be on the sidebar or not, if I remember how to do that. I don't, actually. No, that's not it. That's well, either way, if and when I remember, you can actually drag this to the right side and it won't be on the bottom if you had if you wanted to see this in a long version instead of a short version. I just don't remember how to do that. It's gonna bother me now. Either way, I'll remember it along the way. It's always when you're not thinking about it. Ah, here it is. I can dock it on the left side. I can dock it on the right side, and I'm just using this settings button. I like it on the bottom. It just makes it easier for it to be horizontally friendly to everything that I'm doing in JS Spittle. You can also detach the pane to a separate window. So if I wanted to come back here and say, hey, you know what, I don't want this docked anymore, I can detach it, and you can't see it right now, but I'll switch to the PowerPoint screen, which is my other screen. It is detached to another screen. But I'll reattach it just so that it all stays relative. All right, so it's reattached. Okay. Internet Explorer shows the HTML by default. So if I F12 into Internet Explorer, it will show me the HTML debugger first. I have to go to sources to select a different file. Now, normally, I don't really care about that. I want to see the console. So if I want to go to the console, you see this little thing right here? That's the console button. Just click that, and it'll show you all the errors that you're getting. Now, here's something that a lot of people don't know. If you're throwing errors in your code, 9 times out of 10, the browser is by default written to pause at that error. This will pause at that error. I detest that, because if I'm getting one error, I'm probably going to get a slew of them. So what I normally do when I use IE for the first time, or Edge or Chrome, is I will come in here, and when the error is thrown, or before it, I will tell it, run the entire page, load the entire DOM, then give me the errors. So you don't have to click through this. There's a start thing here, a start icon. You don't have to click through each of the errors. It'll just load all the errors, and you can see where the problems are. Firefox has the same. It'll also stop on errors, so you'll have to tell it not to. But in the console view and the debugger view, I like console. It tells you where the errors are. But the debugger shows you your JavaScript. And sources as I showed you before, sources in Chrome also show you your JavaScript and HTML. But I'm a console fanboy, so I go straight to console to see what my error is. And from console, I can click the link, as I showed you earlier in the video, to show me where the error is in the code. It'll tell me the line, and I can go to that line in the console, or in the it'll take me to sources exactly where that error is being thrown, and fix and tell me how, not tell me how, but kind of give me an idea of what's wrong. So break mode is something that is integral to tracing errors in all code, whatever language you have. And what break mode is it temporarily suspends the program's execution so you can actually look at what the problem may or may not be. Now, that doesn't mean that there is a problem. You might just want to see what's in a variable. You might just want to see what data is available to you then. You might want to see what's happening. So in order to execute break mode, you have to enter a breakpoint. Now, a breakpoint is a statement where the execution enters break mode, meaning that it pauses. The code will stop running at that point. When the program is paused at a breakpoint, you can use debug tools to trace the program execution. Normally, I use breakpoints to find out what's in variables, what's in the array, what's not being passed, why something is null, why a method's not being why a method is throwing an exception. I use break mode for all of that. Break mode is actually one of the more powerful tracing debugging tools you'll ever use. To set a breakpoint, you want to click the line number of the statement where the execution should stop. So let's go back to the code. Let's go to where this error was, and let's click the line. Add a breakpoint. I right-clicked on the side. I can add a breakpoint here, and then what will happen is whenever this line of code runs, it'll stop at that line of code. So let's run it, and there's the breakpoint. Pause in debugger. I have a breakpoint here at this code. And then I can look at what's here. So it paused that bug. I can go to console and write in bug to see if there's anything going on there. Because I paused at the line bug, the line did not execute, or the function statement did not execute. So there's nothing in the variable bug. Now, if I said I want to add a breakpoint here, and I want to remove, well, let me see, I'm sorry, go back. I want to keep going, so I'm going to resume the script execution, and there we go. You see, now it's telling me here in the debugger that bug was successfully initialized and that the array is 3 positions long with these elements, or 3 positions in length, and it's these elements. So it did exactly what it was supposed to do. Yay for logic errors tracing. So you can resume the button as I did on the right hand side using the just look for, if you don't see it, look for the play sign, the play, for those of you who still remember VHS, the play symbol, and it will play it for you, or I'll go past that debug, that breakpoint. And here you go. And I've already pretty much showed you all this, but this is how it works in IE, this is how it works in Firefox, and this is how it works in Chrome. But we went through this in Chrome, so. So to clear a breakpoint, you just click the line number. To clear all breakpoints, you just right-click any breakpoint and say remove all breakpoints or delete all, and all the breakpoints will go away. So stepping through your scripts, or stepping through, is the way that we define the use of a breakpoint. What I just did in the debugger was I stepped through the breakpoint to see if it's doing what it's supposed to do. If it is doing what it's supposed to do, then I can remove that breakpoint because there's no error there that's going to be thrown. However, if it didn't, I can look at it and try to find out why. I can step over a function call, which means that I'm skipping that function statement. I can step out of the function call, which means that I am executing all remaining code in the current function. I can step into a function call by executing an individual line of code. What I did with that in the debugger just now was a step into. And then I stepped out of it. I stepped into it to see if it was a problem, and then I stepped out of it to see what it would do next. I could have stepped over it and ignored that line altogether, but I didn't do that. So a variable list displays all local variables within the currently executing function, and it shows how different variables in the currently executing function affect program execution. A watch list is something along those lines, but it only monitors variables and expressions in break mode. Normally, I use watch list because watch list can tell me what data exists in the variables before the break mode and after the break mode. It can be very powerful to find out what issues you're having either in that function that you've already written, the method that you're trying to call, or in other functions that may not be doing what they're supposed to do. So, to access the watch list, it's displayed by default on the right side of the pane in Chrome. I'll switch over so you can see that. If you look on the right hand side, we're in the middle of a breakpoint, so you will see watch right here, and it's not watching any expressions, but if I scroll down to scope, you will see bug this dot window. This is a quote-unquote watch list, and this is important if you want to know without having to go to the console and type in bug to find out what's there. You can just go to the watch list and see what bug has in it. If I run this again, actually, if I get out of the break mode, run it, it goes back into break mode, and then I go to bug is undefined, meaning bug never had a value assigned to it. It is null, but it never had a value assigned to it. That's what undefined means. If I step through or step out of this break mode, it will then have the value that I loaded or that I assigned to the array bug. Alright, back to the PowerPoint screen. To add an expression to a watch list, you need to locate the instance of the expression in the program, select it and copy it to the clipboard. Click Add to IE or Add Watch Expression as you saw on the left. On the right, paste the expression from the clipboard and press Enter. I'm not going to do that, but if you want to, this is slide 37, and this can give you a lot of information to why things are working the way they're working and doing what they're doing. A call stack is an ordered list of which procedures have been called out but haven't finished executing. Each time a program calls a procedure, the procedure is added to the top of the call stack. Now, we don't have any procedures being executed in our code, but if there was one, we could see that, what's happening and why, in the call stack. If I switch over, the only method that's in the call stack right now is windows.onload, because of course we need to load the screen in the browser. Let me see if I step through this, what'll happen. Yeah, now there's nothing in the call stack. The load is finished. The call stack will only populate, well, for the most part, the call stack populates when there is a break mode initialized, when a break mode is in session. And like in most situations, it's displayed on the right side of the code in IE and Chrome, and it's displayed above the code in Firefox. Or Firebug, however you want to go about that. So bulletproofing your code is writing code to anticipate and handle potential problems. Remember, I was alluding to try and catch. One bulletproofing technique is validating submitted form data. There's the caveat to this that in most situations it is imperative and mandatory on the part of the developer to always, and I will say that again, always validate the data that is being submitted. And that doesn't necessarily mean that you're always looking at formatting as a validation technique. You can also look at something you can also validate the data being submitted as existing or not existing. So for instance, if you have a filter in a page and you want to call a specific thing on the page, let's say somebody has you're making a e-commerce store, and you need to look at a text box or a checkbox or whatever the case may be. And when you look at that text box, you want to make sure that the user actually checked it or wrote in what they wanted. You would look at the text box, and then you would try to see if the text box is empty or not. That's also a form of validating the form. Exceptions handling allows programs to handle errors as they occur in program execution. An exception is error occurring in the program, and we talked about errors, and we, in very brief methods, talked about exceptions handling at a manual level. So we execute code containing an exception in a try statement. So I spoke about try catches a lot before we got to this point. What try catches do for you is they automatically, I like that word by the way, they automatically check to see if there's an exception being thrown at the browser level. So if there's a syntax error, as we saw with bug, the try catch is going to throw an exception. Now that exception is written into the framework of the interpreter. So the interpreter knows this is an exception, I'm going to throw it. However, you can also write your own exceptions. So in this case, we have a try. And var last name equals the document.get element by ID. The ID of the element is lname. We want the value. If last name, remember this is strict equality, meaning that it's got to be the same data type and the same value. What this is literally asking is if last name is null or empty string, not null, I apologize. Null and empty string are two different things. If last name is equal to empty string, I want you to throw an error. Please enter your last name. Now we use the catch statement to handle the error being thrown by the try. The try statement tries to execute the code. If there's an exception, then the catch will fire and throw the exception and stop running the try at that line. So in this case, the windows.alert will throw lname error and return false from this situation. Now, there's try and there's catch. Now there's finally. What finally does is it executes regardless of whether it's associated to the try block or an exception thrown in the try block. And it's used to perform some type of cleanup. So if you want to make an array null again or 0, if you want to reinitialize variables and you want them to be 0 again or null, or if you want to have a tertiary method that, if a specific value you can't, let's say you bring back a value and you can't really control the formatting of the value or the validation of the value, then you'll have a finally that if the try throws an exception, the finally will execute based on the value that's being given to you. It's just a way to continue to have the code run even if there's an exception that's being thrown. So the primary purpose of exceptions handling is to prevent users from seeing errors. You don't want users to see red font on your page. That is probably the most embarrassing thing for developers is to have errors that are thrown to the end user that are not the product of end user input. And it provides a graceful way for developers to handle errors. The reasons for exception handling in JavaScript is to evaluate user input. Very important. User input being evaluated by JavaScript is 9 times out of 10 the hardest, most prevalent error you'll run into when developing in JavaScript. I'm not trying to say that it's always the user's fault, but if we don't validate the data that they're inputting correctly, we then assume the responsibility for those errors. The programmer may write their own error handling code using user-friendly messages and provide greater control over any errors. Catching errors with the error event executes whenever an error occurs on a web page. The name of a function to handle JavaScript errors is assigned to the event listener for error events. And we went over this already. You saw that in the console. Preventing the web browser from executing its own error handling functionality is by returning a value of true from the error event. Now, as you saw before, and I'll go back a few slides, this is a custom error written by the developer. This is not an exception that is inherent or implicit to the interpreter. So, when we are writing our custom error handling functions, we need to make sure that we automatically pass the 3 arguments to the custom error handling function: the error message, the URL, and the line number. It's imperative that you pass those things so that when the error is thrown, the developer knows where to look to fix it. Use parameters in the function, and it shows the user the location of any JavaScript errors that may occur. So, additional debugging techniques are checking HTML elements to make sure that their syntax is correct. Sometimes the JavaScript's not the problem. You might be calling the right ID, but if the tag or the element in the HTML page is not closed correctly, then it would not know that the JavaScript would not be able to bind an event listener to the tag that's not closed correctly, or you don't have quotation marks over your ID in certain browsers. It doesn't like that, so it looks to it as like a variable instead of a literal string. Sometimes the logic doesn't make any sense, and so you're not going to get a error that's inherent to the interpreter. The interpreter might say, hey, everything ran just fine, but your logic is actually not sound. You can test statements with the console command line. We wrote into the console command line to retrieve the value of an array, to retrieve things like that, but you can also use it to run functions in your code, to initialize certain things. You can do a lot in the console. Using the debugging statement of try catch is imperative. Trying to see where to catch these errors and how to remediate them without having to step through your code yourself can help you go the distance in catching a lot of the errors that you yourself might not catch on your own, and to save you time when you get to that manual debugging process. Remember, you're not always going to catch all the errors automatically. So it's imperative that when you do receive an error, you step through your code yourself to find out what the problem is. But in larger files and larger codes, in larger code structures, not having a automatic way to look at your exceptions can really drive up the time that testing would take in your project. Executing code in strict mode. This is something we didn't talk about today, but in chapter 3 we talked about strict HTML. In strict mode, things can be a lot more constrained. Remember that JavaScript is a loosely typed language and it's dynamic, so it gives you a lot of leeway in what you can and can't do. Executing your code in strict mode will give you the ability to see how it's supposed to operate with every rule applied. Linting is an advanced way to debug techniques. I won't talk about that here. And obviously reloading the web page, as you saw me do over and over again, can give you the peace of mind to know that it works, but also see if any other errors are being thrown after you've remediated the error that you found. If a bug cannot be located using the methods described in this chapter, then yes, you'll have to perform a line-by-line analysis of your HTML code. Tuna.js has some syntax errors in the code, so if it's not running for you, please go into your syntax, see what is written incorrectly. Do not assume that the developer before you did their due diligence to find out if there's no errors in the code syntactically. There are errors in Tuna.js. They were found this weekend by one of the students. So please look at your code and make sure that when you're doing your guided practices that you're not beholden to the errors of the past developer. Not all errors are your fault. Remember that. Ensure all necessary opening and closing tags are included. Syntax errors. Use code editor specialized for web development. JS Fiddle, you can use Notepad++, but remember, JS Fiddle actually will tell you what the error is. So if you want to use JS Fiddle to write your code and then place it in the HTML after the fact, go right ahead. I don't mind that at all. Use the W3C markup validation service to validate a web page. Now, there's a W3C page out there, you can Google it, that you can actually place your HTML file in, your JS files and all that jazz, and it will tell you whether or not you have some issues with your file. That's another way you can kind of use a third-party IDE, if you will. I mean, it's not an interactive development environment, but it is an interpreter that can tell you what's wrong. If you don't want to use the debugger and the console in the Chrome, I'm telling you that the debugger and console are way more powerful than anything else you can use otherwise, so I would implore you to use what's at your fingertips already. So some JavaScript code errors stem from logic problems. It can be difficult to spot on tracing techniques because logic errors are not always thrown as an exception or an error. Just because it's a logic error doesn't mean that it is a syntax error. Analyze each statement on a case-by-case basis to find out if your data is coming out the way that you want it to. For instance, don't say that you divided something when your algorithm is multiplying. That is a logic issue, and it won't throw in your code unless you expressly write a custom error to throw that. Now the console command line is what I showed you how I found out that the bug array was undefined, and then how I saw that the bug array then had the 3 elements in it. It's very powerful. You can execute functions from that. So if I had a function in my page, for instance, let me just, for shiggles, go back, and let's say we'll just encapsulate all this in, I'm breaking my own rules, encapsulate this in a function, and then let's go to console, and let's run it. As a matter of fact, let's clear the console. Let's run it. Nothing will be in the console. Now, what I can do here is I can execute buggy fresh, and I will get an error. It's not, buggy fresh is not defined. Why is it not defined? Did I spell it wrong? All right. I should be able to execute this. Well, either way, what I could do is I could take that out and then say run console, go away. I see what's going on. All right, I have breakpoints. Disable breakpoint. Disable breakpoint. Let's try it again. We'll just say buggy. We will do that. Let's run it. Console. Let's empty this and run it again. And let's try to execute buggy. Interesting. Maybe it's trying to execute a method that is inherent to the library that I'm not calling. Either way, you should be able to do that. I can't do it right now. I'm not going to waste any more time trying to make it work. But from this method, or from this console, you can look at a slew of things. I can look at bug. So if I commented this out and said run, and then said bug, it'll give me nothing. What? Reference error. That's weird. It should have given me bug. Sources. Watch. Alright, now that's weird. Var bug equals. It should have given me what's in bug. Bug is not defined. I wonder why that is. I wonder why that is. Because it worked before, didn't it? Maybe it's something that I'm doing wrong. Let's try that again. Let's say bug, var bug equals hey. And then let's close that, run it, and say bug. Wow. Okay. It worked before. I don't know why it's not working now. I will have to investigate that. But essentially, from the console, I should be able to see what's in bug. As a matter of fact, maybe I didn't write bug to the console and that's why it's not doing it. Run. Bug. Ah, it's still not working. Weird. Alright, well, it worked before. I just got to find out why it's not working now. So you enter the JavaScript statement at the command line in the web browser console. You include multiple statements at the command line and separate statements with a semicolon. You can run full function statements in the console. I'm not really doing an adequate job of that right now, but there's something wrong. I don't know why it's not working. It worked earlier in the video. When you include the debugger statement in your code, the web browser stops executing JavaScript code when it reaches the debugger statement. It's the equivalent of a breakpoint. So, strict mode removes some features from JavaScript, and it requires more stringent syntax for other features. It is very strict. The way that I'm developing right now is not adequate for strict mode. You would need to add a lot more to your script section for the strict mode to work correctly and you not get a slew of errors. But it's included at the start of your script and requests a strict mode for all code in that section. And including it at the start of your code block in the function request strict mode just for that function. So you can have use strict globally in your JavaScript, or you can have it just for a specific function. Running code through a program that flags some common issues that may affect code quality is also called linting. JSLint is a commonly used linting program. Node.js is also used for debug, so I'm not sure that linting is as prevalent as it used to be, but I could be wrong. I don't use linting, but I also do code testing in Node.js. Linting uses strict mode, but generates a report containing line numbers to tell you where the errors are. Reloading the page doesn't always clear the page of the memory, so if you want to reload it correctly to be a completely new web page, I think it's Shift F5 or something along those lines. Yep, here it is, Shift F5. And it will force a actual fresh reload without the cookies, without anything else into your browser. And you may need to close the browser completely, all of them, not just your tab. If you don't close all of them, it'll still hold the cookies. And you may also need to go and delete your internet history to get rid of all the frequently visited websites, because caching is a thing. It makes life a lot easier for a lot of end users. And if you want your cache to be cleared, you'll have to close your browser completely. There are three types of errors, as we will summarize this chapter. There are syntax errors, which are errors in the way that you wrote your code because it's breaking the rules of the way that it's written. There's runtime errors, which are errors that can occur because of a syntax error or not. And there's logic errors, which may not always throw an error, but your data might not be right, or the data that you're pulling back from a specific, call or whatnot might not be correct. As we saw in one of the slides, you had a multiplication fact, but we were calling it a division fact in our string literal when we were printing it to the page. So error messages are our first line of defense in locating bugs. Manual tracing, basically manual tracing, is the examination of individual statements in executing a program. It can take a long time and longer written, and when you have a script or a program that has a lot of moving parts, or it can be shorter in a program that doesn't have a lot of moving parts. You can use the alert method to trace data within a data object. You can also use console.log, which is my favorite. And you can see those different paradigms in the browser debugging tool for Chrome, whatever the case may be. Break mode is a temporary suspension in the execution of the code. So it will suspend the execution of the code at that line. And break mode is very important when you want to see what is happening at that specific point. A break point is a statement in the code at which the program execution enters break mode. Break mode is great for when you want to see why the data is coming across the way it is. Is there a problem logically where the syntax error actually exists, or if normally it's to see data flow. You want to see if the data is flowing the way it should flow. You can step into a breakpoint, and what that essentially means is that you're looking at the line that the code broke at, or is at break mode with. You can step over it, meaning you're skipping the line that the breakpoint is annotated for. And you can step out of the break mode, meaning that you said, okay, I'm cool with what's in this breakpoint. I don't want to see anymore. And then you hit the play button and it'll step you out of the break mode. on the right hand side of the console for IE and Chrome, and at the top for Firefox, Firebug, you have your variables list that'll show you what is contained in each variable at the break mode. Once you're not in break mode anymore, it won't show you the variables list. We saw that. And it also will stop showing you the watch list unless you implicitly or explicitly stated you want to see this. The call stack is a list of procedures that have started but not finished. So the call stack in break mode shows you what was executed, but it's not finished yet. And when we looked at our break mode for the call stack, onload was not finished yet. Once we left the break mode, onload left the call stack list. Bulletproofing is writing code to anticipate and handle potential problems. You will always have errors. I'm not going to say 100% of the time you'll always have errors, but probably 99% of the time you will run into an error in your code. Maybe you were coding for too long and you wrote the syntax incorrectly. Maybe you had a brain fart and your logic just isn't sound. On paper you wrote your logic, your pseudocode is written correctly, but it just is not coming out the way it should. You can have a runtime exception based on maybe a specific method that you thought a browser could execute, can't execute it. We talked about this in Chapter 3, where there's an attach event method for IE8 because add event listener, the add event listener method does not exist in IE8. So we check to see if add event listener exists as a valid method to a specific HTML element based on the browser that we're using. And if it doesn't have that ability, then we ask for a different method that may exist as a part of the library of that browser or the interpreter. We use exceptions handling to give us errors that we ourselves might not necessarily see. And we'll use try, throw, catch, and finally statements to give us that warm and fuzzy that our code is written correctly, and by Jove, we can put it into production. Or throw the error and then catch the exception. And then if we don't really care about that exception, or we still want the program to finish, we run our finally statements. So JavaScript will include an error event and execute whenever an error occurs on a web page. Additionally, debugging methods and techniques check HTML elements, analyze logic, use the console command line, use debugger statements in your code. If you feel inclined, use strict mode, try linting. In production or in dev teams, you will find that moreover we'll use Node as a unit testing methodology for JavaScript, or reloading the page to see if you just have data that's cached and it's just not working out. And that's it. I hope this has helped you. This once again was Chapter 4, debugging. Debugging is the hardest thing that a developer can learn how to do. But once you master it, it's not that difficult. It's time consuming, but not difficult. You will find that when a project manager looks at a project, the part of the project that takes the most amount of time is not the development. It's the testing. The development is the easy part because you already know what you need to do. It's the testing that's the hard part. Because in testing your code, you're finding out if it's doing what it's supposed to do, or if your assumptions for what it's supposed to do are accurate. If they're not accurate assumptions, then what you get is either logic, runtime, or even syntactical errors. It's been fun, and I hope that this chapter actually helped you. I look forward to more chapters with you in the future. You have a good one. Ciao.